we talked about a rate, time, and distance problem. We talked about a couple of proportion type problems to set up. So what I want us to keep in mind, yes, so we've got our 5-step word problem solving method, but also we've learned some equation solving skills along the way. When we first started discussing word problems way back in even August and September of this year, a lot of the skills that we had were limited to just, basic solving one-step linear equations. And now we've expanded that ability to solve things like rational equations, quadratic equations, and the like. We also have background information like dirt. Remember, we talked about distance equals rate times time yesterday. And then we also have a chart that is helpful as far as organizing the information. So when we jump through these problems and you're working examples, I want you to kind of keep in mind some of this background information. All right, so Jasmine trained for 3 hours on Saturday. She ran 8 miles and she biked 24 miles. Okay, and so her biking speed's faster than her running speed. What's her running speed? I was encouraging that we did word problems yesterday with the freshmen as well as my seniors in calculus. And in all of those classes, I was encouraging them, look at the last part of the problem. Read like the last sentence. And a lot of times what that will do is that will clue you in on what the problem is asking, which is step 1, and what you want your variable to be, which is step 2. So in this case, it says, what's her running speed? I'm going to let X be her running speed. All right, so I'm going to say let X equal Jasmine's running speed. And so I could express, as we've talked before, I could express her biking speed in terms of X. Okay, Reed, give that to me. Yeah, X plus 4 equals her biking speed. Okay. Now, if you think about the problem, step 3 is setting up the equation. We don't really need a chart for this because we're told that her total time was 3 hours. And yesterday we had an expression for time. Does anybody remember what we said time equals, considering dirt and sort of tweaking that dirt formula a little bit? What did we say, Luke, that time equal? Yes, sir. Distance over rate. So in the back of my mind, I'm thinking, oh, okay, if I can do distance over rate for the running plus distance over rate for the biking, then I can set that equal to the number 3, okay, because it says total of 3 hours. So if her time spent biking is, or excuse me, her time spent running is 8 over X, that's distance over rate, and her time spent biking is 24 over X plus 4, then that's going to equal 3, which is our total number of hours. Okay. So again, in red there is sort of the background info that Luke quoted for us that we have to understand about a problem like this in order to work it out. And what kind of equation is this, Alex? It's not a linear equation. Paul, as you put your mask up, what kind of equation is this? It's not a proportion yet. We could make it one. It's a rational equation. We talked about rational equations and how to solve them in 7.4, and Paul has mentioned one technique that we have, which is to set up a proportion, right? Combine the 2 fractions over on the left such that it's a fraction on the left and a fraction on the right, and then cross multiply. But we're not going to do that here. I would recommend multiplying both sides by the LCD, right? That's a little bit more of an efficient way of doing it. Now, the LCD is an expression that contains each denominator. So, Charlie, we think the LCD is going to be here. Okay, so if I were to multiply X plus 4 times each fraction, I got to do it on the right side as well. It will certainly kill off that middle fraction. It will certainly, I would cancel that factor of X plus 4 and X plus 4. I cannot cancel X here, though, because that plus sign is linking them together. It's a roadblock. This would be the equivalent of if I had, 1/3 plus 1/5 equals, I don't know, we'll just say X. And I said, and let's multiply both sides by 5. Which fraction would that kill off? The middle one. It would not affect this one because I did not include 3 in the denominator. Okay, so I would have to include, I'd have to do 15, 15, and 15. You know what I mean? So what, can you amend your answer for me there, Charlie? What else do you need besides X plus 4? Ben, what do you think? Yeah. Well, in other words, what would kill off the denominator on this first fraction is just an x. So I need to put an x alongside that x plus 4 on each of these. And remember, you can do whatever you want on the left side of an equation as long as you do the same thing on the right. So if I want to multiply by the quantity x times x plus 4 on the left side, I have to do it to the entire left side, and then I have to do it on the entire right side. Okay, Grove, help me cancel some fractions now. What's going to cancel out on the first fraction? All right, we're going to be left with 8 quantity x plus 4. And some of you alpha dogs, y'all can probably go ahead and do the distribution in your head and get 8x plus 32. I'll show that step in the next one there. Let's see here. James, what cancels out in the middle fraction? Yeah, the x plus 4. It's going to cancel out in the middle fraction. That leaves me with what, class? All right, 24x. And then the right-hand side was not a fraction, so nothing's going to cancel. So I'm going to be left with 3x, x plus 4. Again, if you're an alpha dog, you could distribute and get 3x squared plus 12x. But now we've got not a rational equation, okay? George, what kind of equation do we have now? Once I do my distribution, what'd you say? Quadratic, right. Because that right-hand side is going to have a 3x squared on it, okay? So 3x squared plus 12x, 8x plus 32 plus 24x, okay? Combine like terms, okay? So what do I want to do, Jack Candiato, to both sides to combine some like terms? What's a negative? What do you mean negative 12? Oh, you want to do it that way? Oh, you're one of those guys. I'll play ball. I'll play your clever games, you rogue. Let's subtract 12x from both sides. Okay. So we got 3x squared equals 12x, and 8x is going to leave me with 20x. And I got 32. Okay, so Jack suggested we subtract 12x from both sides. Put it together with those other. There's an x term. There's a couple of x terms. So we put all that together, and we got 20x. Okay, now what? What do you want to do now, Drew? You don't know? Well, your butt better call somebody. Anybody? No, not the math thing, the reference. Nobody? It's like 20 years ago, there was a WWF wrestler or WWE wrestler that would say something to that effect every time somebody's like, I don't know. And he wouldn't say but, he would say another word. But he's like, you better call somebody. I can't believe y'all don't know that. I don't know who the wrestler was. It's not John Cena, but it's somebody popular like John Cena. Y'all have no idea what I'm talking about, do you? Dadgummit. All right. It would have been hilarious about 15 years ago. Quentin. What the? No, we don't want to divide by x. We got a quadratic equation. And to solve quadratic equation, we need, we're going to go back to Drew Benton. Drew Benton, chance at redemption. Speak up. How does the zero product property work? It must first be what? What was the first word out of your mouth? Yeah, we got to set it equal to 0. Good. Now, this is where I was saying Jack was being a bit of a rogue. He was moving stuff over to the left side. And if I did that, if I subtracted 3x squared from both sides to make it 0 on the right, Jake, why don't I like that as much? Because the leading coefficient, that quadratic term, is negative. I'm not a big fan of that. Okay, James. 3x squared minus 20x minus 32, opposite of 0, 0. In other words, just multiply everything by -1. So if you move everything over to the left side and the leading coefficient is negative, I would encourage you to, just as James said, make everything negative, or excuse me, multiply everything by -1, changing the sign of everything. Now we've got something that should factor out. Tiago, what method will we use to factor it out? We will use the magic method. All right, let's see how that works. Over here on the side, I'm going to do a little scratch work. We got x squared. Y'all help me. See if you can beat me to it. 3 times 32 is 96, I guess. Minus 96 equals 0. So I want some factors of 96. 2, 48. Nope. All right, so 3 and 32. Oh, you got it? What is it? 8 and 12. Hot dang. Oh, one of them's going to have to be positive. One's going to have to be negative, though. Remember, because the 96 is negative. All right, I'll put 8 and 12, but I'll put it down a little bit lower on the list. 4 and 24. Ooh. Did you hear what I just said? 4 and 24. All right, now I'll actually stop there because a 4 and a negative 24 will work. Good try, though, Quentin. Good try. All right, so let's see here. What do we think? X plus 4 and X minus 24. Lewis Thomas, what's my next step in the magic method? I'm over here on the side in green kind of pretending. What do I do, remember?
You write it as in parentheses, like, and then you add back the 3.
Oh, hold on, dadgummit. I can't hear you. I swear, Microsoft Teams likes to just jack with me every once in a while, just to keep me on my toes. Hold on, Lewis. Settings. Devices. Display audio. All right, go for
it. You have to bring back the 3 in front of the X.
Mighty fine, sir. Mighty fine. We're gonna put the 3 back. If there's a common factor, then we'll kill it off. So we got 3. 24 is 8. So this one's gonna be 3x plus 4 and x minus 8 equals 0. Now, Drew Benton mentioned the zero product property. Okay. So let's see here. Alex, we'll ask you to give one of our 2 resulting answers. And I'm going to push you guys to do these in your head. So Alex, whichever one you want, give it to me. 8. All right. He took the easy one. Joey, you got the other one? Negative 4/3. All right. Now I'm going to zoom back out because we have now found 2 answers. One of which is extraneous. Nate, which one's extraneous? Negative 4/3 or 8? All right, and what makes you say that? All right. What does X stand for? We solved for X. We said X equals this or X equals that. What does X stand for at the very top in blue? Running speed. So I want you to reassess your answer. Which one of these 2 is extraneous? And tell me why. Yeah, she ain't running backwards, boys. Okay. And so it would not make sense in the context of the word problem, right? To say, yes, I'm traveling at negative 4/3 miles per hour. First of all, that's stupid. Nobody's going to run that slow. Okay. That's like barely a walk. And second, it's negative. So we would consider it to be extraneous. In other words, we would throw that answer out and we would say, oh, okay, look, X equals 8. 8 is her running speed. Now, back to another point that Nate made. I love how he goes back to the blue equation, that rational equation that we were solving. And when we plug in our answers, we want to make sure that they don't make the denominator what? We don't want a denominator of 0. And so we're gravy because X is 8. They just happen to make that first fraction 1. No big deal. And then X plus 4, that denominator would be 12. Again, no big deal. Okay? So when we're working through these word problems, look for the what, Mossy? Did you blank out on me? Make sure that our answers are not extraneous. Extraneous. Okay, it's like an extra anus. You just don't need it. Get rid of it. Throw it out. All right, questions on example 4. That's a little bit tougher, wasn't it? Okay, the setup and the solve were both a little bit tougher than the average problem, and that's okay. I want y'all to try this rate, time, and distance problem. This is a round tripper. I call this round trip because remember, a round trip problem is where the distances are typically equal. Like if I drive there, yeah, I'll zoom in. If I drive there and I drive back using the same route, then my distances can get set equal to each other. All right, so this is what's called a round trip problem. And what I'll do is I'll give you guys a couple minutes, at least set the equation up here, okay? At least set the equation up, and then we can work on the solving of it together. I'll be right back. Yes, Paul? You could do that if you want to. All right, so you've been working for a couple minutes. I quietly sort of put together a chart. I don't know if you see it up at the screen, or if you've been looking yet or not. You might have considered working the problem a little bit differently. Paul mentioned the way he did it, using x for the downhill speed and the x minus 8 for the uphill speed, and that's fine as well. I typically like to let the smaller unknown be my variable, right? And there's a couple unknowns in this case. So when we read the problem, they give us some ambiguous information about not just the rates, but the times as well, hence the use of two variables here. Okay, don't be afraid to use two variables. You guys have learned how to solve systems of equations, right? What were those three techniques? Yeah, elimination, substitution, graphic. Now in this case, I've got a couple of equations written up there in orange. What do you think we should use to solve this kind of system? It's a nonlinear system. In other words, would there be an easy way for me to eliminate one of the variables? So we should probably try and use substitution. Okay. Make a note that with nonlinear systems, substitution is usually the way to go. Okay. So for example, what I could do, and I'm going to zoom back out now. Okay. What I could do is I could just take this first equation and solve for y. Y equals what? 12 divided by x plus 8. Your hesitancy is a little unsettling there, folks, right? All we have to do to get y by itself is use the inverse operation, divide both sides by x plus 8. Now, we're using substitution, right? So what does that mean I could then do, Joe? To the other equation. All right, and that's going to produce the one equation, one variable, one equation type setup that I'm looking for. All right, so I got x, instead of y plus 2, it's 12 over x plus 8 plus 2 equals 12. And now we're going to get down to the solving of it. Okay, we're going to get down to the solving of it. First thing I would consider doing is dividing both sides by x. Okay. Now, what kind of equation is that? We've been dealing with them in the last section. So 7.4 was all about what kind of equations? Rational equations. And there were two techniques for solving rational equations. One technique was to combine the terms on one side and make a proportion, and then cross multiply said proportion. I don't like that approach. I instead want to kill all the fractions. And what would I need to do to kill all the fractions? Louder. Louder. Multiply by the LCD to kill all the fractions. All right, in this case, can you use inspection to tell me what the LCD is? What is it? X and x plus 8. Very good. So I'm going to times each term, in other words, the entire left side and the entire right side, by x quantity x plus 8. It's going to multiply by the first fraction, by the second term over there, and then, of course, if I do it on the left, I got to do it on the right, x plus 8. Okay? Now, I ask the same questions over and over again. What cancels and what's left over? Okay? Grove, what cancels on the first fraction when I multiply? And what's left over? And? Thank you. 12x. Right, remember, we're putting both of these guys up top here with the 12. And can I go ahead and physically write them up at the top in every term? Sure, I can. But I'm pushing you guys to be a little bit more efficient, okay? So save yourself some time. Focus, by the way. I'm seeing some glossy looks. What we did was we just said x plus 8 goes on the top here. The x plus 8 cancels out. We're left with 12x. What cancels out on the second one? Nothing. Trick question, right? So you're left with 2x and then x plus 8. And again, if you want to be an alpha dog, then you can go ahead and do all that distribution business. All right. On the far right-hand side, Mossy, what cancels out? Doesn't cancel out. What do you see on the top? That's also on the bottom. And x is going to cancel out. You're not off the hook yet, though. What do we have left? And it's like Pete and repeat, fell off a fence. What's left over on the original numerator besides the x plus 8 now? We got x plus 8. What else is up top of that fraction in green, in the parentheses? Yeah, 12's there, right? So when we cancel out the x, we're left with 12 and x plus 8. Okay? And again, let me encourage you guys, physically write the LCD at the top of each and every fraction. Okay? I didn't do it in this example. I think I might have done it in the last example. Yeah. Like, if you want to, physically write it up, just like we did in green on that last example. And then you can physically just scratch out each denominator, and then you got left over. Oh, look, there's an 8 and an x plus 4. Oh, look, there's a 24x. Oh, look, everything's left. Physically scratching things out, canceling things out after you write the LCD is a good basic step. And then once you get a little bit quicker, you don't have to physically write the LCD in every case. You can just mentally answer those two questions. What's canceling out and what's left over? Okay. Andrew, combine some like terms. All right. Might I recommend, before you add it to 12x, consider what's on the other side as well. Go ahead and distribute that 12 on the other side.
12x plus 96.
All right.
12x.
Now you're smelling what I'm stepping in. So we had a 12x on the left. Now we have a 12x on the right. So let's just cancel both of those out. And again, you're showing steps. You're doing work. I'm encouraging you guys to become proficient at doing a little bit of mental math as well, though, right? But we don't want to forget what else he told us. We had 2x times 8, which was 16x. So I probably prefer subtracting 96 at this point, right? And dividing everything by 2. So minus 96 equals 0. Dividing everything by 2 is going to make it factor a little bit easier. What's 96 divided by 2? 48? And can you guys tell me 2 factors of 48 that add up to 8? Negative 48 that add up to 8? 12. Negative 4. All right. And that means that my 2 answers will be negative 12 or positive 4. And we go back in the context of the problem now, and we see, is anything extraneous? Negative 12 would be very extraneous, because although he's going back uphill, it wouldn't make sense for us to say, yes, that speed is negative. Okay, you guys will go into high school and you'll take a class called physics, and you'll learn that there's a difference between speed and velocity. Speed is what's called a scalar, and velocity is a vector. Velocity can be negative, but not in the daggone context that we're in right here. It's not, we're not saying he's going uphill at negative 12 miles an hour. That's kooky, because then he would be going back downhill. What's negative 12 plus 8? Negative 4 miles an hour. Does that make any sense? No, of course not. So we'd throw out that negative 12, and we'd say, okay, if he's going uphill at 4 miles an hour, how fast is he going downhill? He's going 12 miles an hour, which is what they were asking us to find. So we want, again, going back to Paul's point earlier, we want to make sure that we answer the question. It's not always just, hey, what does x equal? And then, all right, I'm finished. Answer the question that they're asking. Okay. Again, today, 2 word problems that we just kind of chewed our way through. Not easy word problems. Not all word problems are meant to be, kind of one and done. But we'll look at the process that we're following. In one of these, I used a chart to help kind of organize things. But we're considering, what are they asking? We're considering, what do I want my variables to be? We're taking time to write an equation. And then now we're getting into the part where the equation solving, Paul, cover your mouth. I'm tired of telling you that. The equation solving is not easy, okay? But we've practiced it, right? We've practiced doing it, and you can follow step by step and just take your time. If you need a little bit of extra practice on solving those types of equations, right, you can go back to section 7.4. We've got a buttload of, come on, 7.4, there we go. We just got just numerous examples of solving equations with fractions in them, okay? And the equations that we've been encountering in the word problems are on the easier side. Some of these, like down here, they're a lot harder. Okay, so challenge yourselves. Be practicing. Okay, and I'm going to cut you guys loose. When will I see you again? All right, well, that is a good question then. How many of y'all do not have school on Friday this week? Good, googly moogly. All right, well, I guess that I will put up some videos and have you guys watch. I can't go a whole daggone week without seeing you guys, or y'all gonna get way too far behind where I want you to be. So just check my YouTube channel, okay? I'll be putting up lessons. You watch them, take notes, practice. Check Delta Math for some assignments to practice through as well. And y'all have a wonderful day. Live Jesus in our hearts. Okay, thank you so much, fellas. I'll send your parents an email regarding what I just said.